For chapter 6, the normal distribution, you can see that bell curve shape right in the beginning of the textbook. And this is a very natural shape where we have a quantitative variable with an average that's potentially known. It's going to have to be known for the problems that we do. And then it's dispersed according to kind of this predictable curve. Essentially, many are grouping towards the middle. As you get farther and farther above or below average, you find fewer and fewer of those measurements. And so you could think of like pick a different dog breed and measure its average height or something like that. You have, that most of these dogs are going to be grouped up close to average. You're going to find some that are quite a bit taller, and you're going to find some that are quite a bit shorter, but it will have this natural tendency. Sometimes maybe with a little skew one way or the other, but a perfectly normal distribution is symmetrical around that mean. So I'm going to talk about some of the concepts like the standard normal distribution, and then just how we use a generic normal distribution for different problems. So I'm going to go to Desmos, eventually we'll work our way up here, but I want to start with just a normal dist function, and it asks for the mean and standard deviation. If you put nothing in there, it's 0 and 1. So this is the most basic way you could use Desmos to look at the normal distribution. And you can also use Staplet to do the same thing. I have another video where I give you some more examples, but we'll take a look at the concepts with Staplet in this video. So you go to probability, normal distributions. Let's start with just that mean of 0 and standard deviation of 1, and we can see that same thing. Now this one is zoomed out. If you hit the zoom fit button underneath the color, it will zoom it a little better. Now this has some extra information. If I go to my graph settings, I really don't need the grid. A lot of times we just remove that y-axis. As we talked about in the last video for chapter 5, a continuous distribution, the height is not really what we're concerned with. It's the area, the shaded region. And we're not going to be able to use just a width times height here. We're going to have to use technology to calculate that cumulative probability. So really we don't need a y-axis. That's not going to be helpful for us. And this is how I usually graph it. So now let's say you want to find a cumulative probability. Check the box, and the entire region is 1, as it should be. And let's say we want to just find the cumulative probability of that second standard deviation. So we have each of these tick marks, each of these units on the x-axis is 1 standard deviation when I have a mean of 0 and a standard deviation of 1. So essentially I'm setting x equal to a z-score. And that is one of the first things that you'll see here in 6.1. Z-score is the number of standard deviations above or below the mean. So if we just look at this, what's called a standard normal distribution or a standardized normal distribution, we just measure the number of standard deviations from the mean. So it's kind of like a hypothetical. If you were 2 standard deviations above the mean, what's your percentile rank? 97, closer to 98th percentile. And if you want to find the probability of being between 2 values, you can use a min and a max. So that's about 95% within 2 standard deviations above and below the mean. So this is a really great tool to be able to use Desmos in this way to see a graph. And then when you get to problems from 6.2, you can input a mean. So say, for example, the mean of this population is 45 and the standard deviation is now 5. So I'm first just going to graph it, and I'll do the zoom fit again. And now this automatically figured out that I want units of 5 on the x-axis, but it might not always do that. You might have to go in here and put a 5. And now my cumulative probability. So now being within 2 standard deviations of the mean, z equals -2 is 2 tick marks over. As long as I'm going by that standard deviation, so that's 5, 10. 10 units below the mean is 2 standard deviations below. So I'll go from negative 10 to positive 10. It's 2 standard deviations. Oh, whoops, negative 10 from 45 should be 35, and positive 10 from 45 should be 55. There we go. So 10 units below. And the formula that we have is in the book. It's this mu plus z times sigma, or if you're finding z, you can solve that for z. So we're doing 45 minus 2 times 5, 45 minus 10, and then plus 10. Same thing, 95% within those 2 standard deviations. So now this is no longer standardized. It is contextualized for a specific problem, specific set of parameters. And now we would have to just think of z in our heads or use the formula from the text. But for the most part, we're not too concerned with z. We want to be able to visualize, kind of like these tick marks being z equals 1, 2, 3, negative 1, negative 2, negative 3. And going back over to Staplet, the way I would use this is put in that mean of 45, standard deviation of 5. The x-axis is automatic, and down below is where you select what you want to do. So for example, from negative 2 to 2, or I said it would be from 35 to 55 for this problem, is that 95.45%. Standard normal, 0 and 1, negative 2 to 2 on there. And then you can also show labels, which can be helpful, especially when you're in a contextualized distribution. Here you can see that the labels switched from z to x. It's going to be smart to figure out what variables those are down there.